Hello viewers, in today's class we are going to discuss one very interesting problem from algebra, and here we are going to solve these two equations, right? So in this video we are going to solve these two equations, and if we closely look at these two equations, we can see that these two equations are homogeneous equations, right? So now before solving these two equations and to get the values of x and y, let us analyze these two equations, right? So now if we see the first equation, then we can see that the degree of this equation is 3, right? Okay, so now let us first write this first equation in the form that is we can take x cube common from the the left hand side, right? So we have x cube, and here we have 4 plus 3 times y over x plus y cube over x cube, and that is equal to 8, right? Now let us do the same process for this equation. Now here also we can see that the degree of this equation is 3, right? So let us take x cube common from the left hand side. So we can have x cube, and here we have 2 minus 2 times y over x plus, and here we have y square over x square, right? And here we have 1, right? So now if we closely look at these two equations, we can see that here we have x cube, here also we have x cube, right? And the second term or the second factor is a function of y over x, right? So see, here we have y over x, and here we have y cube over x cube. That is y cube over x cube can be written as y over x cube, right? And similar is the case with this equation, right? So now what we will do, let us designate this equation as 1 and this equation as 2, right? And let us divide equation 1 by equation 2. So when we divide equation 1 by equation 2, we can see that x cube and x cube get cancelled, right? And we are left with 4 plus 3 times y over x plus y over x whole cube, because this term can be written as y over x whole cube. And here we have 2 minus 2 times y over x plus y over x whole square, and here we have 8 divided by 1, right? So now we have this equation, right? Now if we closely look at this equation, then we can see that the numerator and the denominator both are functions of y over x, right? So now we can write this entire equation like this, that is f of y over x is equal to 8, right? So here the numerator is a homogeneous function of degree 3, and the denominator is a homogeneous function of degree 2, right? So now to solve this equation that is 3, which is a combination of these two equations, right? So we have merged these two equations into this equation number 3, right? So to solve these type of equations, we have a very interesting method, right? So here what we will do, we'll substitute y is equal to mx, right? So here I will make this substitution. So when we take y is equal to m of x, so it implies that we can take y over x is equal to m, right? So now if we take y over x is equal to m over equation number 3, and then we get this expression, that is 4 plus 3m plus m cube is equal to is divided by 2 minus 2 times m plus m square is equal to 8, right? So now we can see that this equation is only in terms of m, right? And this m is connected with y and x. So now let us simplify this expression. So we have 4 plus 3m plus m cube is equal to 8 times 2 minus 2m plus m square. So we can now write 4 plus 3m plus m cube is equal to 16 minus 16m plus 8m square, right? So now we can simplify this expression to get a cubic polynomial in m, right? So we have m cube. Now here we have 8m square, so we can take it here. So we have minus 8m square, and here we have minus 16m. So when we take this 16m to this side, we have plus 3m. So this is 19m. And here we have 4 minus 16, that is minus 12, right? So now we have obtained a cubic equation in m, right? So now this is a cubic equation in the variable m, and m is connected with y and x by this equation, right? So what we will do here, we know that a cubic equation has three roots, right? And here we'll try to first find out the three roots, that is we'll find out the value of m, right? So for this we'll take help of a simple algebra from earlier classes, and here we'll make use of the factor theorem. So now let us consider the polynomial f of m, that is m cube minus 8m square plus 19m minus 12, right? So now by hit and trial or the guess method, we can see that if we take m is equal to 1, then f of 1 is equal to 0, right? So this is quite evident by taking m is equal to 1 in this expression, that is 1 cube minus 8 times 1 square plus 19 times 1 minus 12. So we have 1 minus 8 plus 19 minus 12. So this is equal to here 19 plus 1 is 20, and here minus 12 minus 8 is 20. So this is 0, right? So for m is equal to 1, f of 1 is equal to 0. So we can conclude that m minus 1 is a factor of f of m, right? So now to get the second quadratic factor, we can divide f of m by m minus 1. So now let us divide f of m by m minus 1, right? So here we'll make use of the usual method. So here first we'll take m square. So we have m square times m is m cube. Then we have minus m square times minus 1 is m square. So here we have minus, here we have plus. So this is minus 8 m square plus m square is minus 7m square plus 19m minus 12, right? So now we can take here minus 7m. So this is minus 7m square plus 7m, and here we have positive sign, here we have negative sign. So here we have now 19 minus 7 is 12m minus 12, and now we can take here 12. So we have 12m minus 12. So now these two terms get cancelled, right? So the quadratic function is m square minus 7m plus 12, right? So now f of m is equal to 0 can be written as m minus 1 times m square minus 7m plus 12 is equal to 0, right? So now we can factorize this quadratic term by splitting the middle term. So we have m minus 1, here we have m square minus 4m minus 3m plus 12 is equal to 0. So this is m minus 1, and here we have m minus 4, and this is minus 3 m minus 4, and now we can write m minus 1 m minus 3, and then we have m minus 4 is equal to 0, right? So now from here we have got three values of m, that is m equal to 1, then we have 3, and then we have 4, right? So this cubic polynomial has three zeros, that is m is equal to 1, 3, and 4. So viewers, we have got three values of m here, right? So for m is equal to 1, since we have already assumed that y is equal to m of x, so when m is 1, so y is 1 times x, that is x, right? And when m is 3, we have y is equal to 3 times x, that is 3x. And when we have m is equal to 4, we have y is equal to 4 times of x, that is 4x, right? So from here we have y is equal to x, from here y is equal to 3x, and from here we have y is equal to 4x, right? So now once we have obtained the value of 1 m as 1, 3, and 4, we can now write the values of x and y by using these relations and substituting these relations one by one in any of the two equations. So now let us first take this one, right? Because this relation corresponds to m is equal to 1. So when we take y is equal to x in any of these two equations, now let us prefer the first equation. So what we will have, we'll have 4x cube, then we have 3x square times x plus x cube is equal to 8. So this is 4 plus 3 plus 1, that is 8x cube is equal to 8. So we have x cube is equal to 1, right? And this allows us to get the value of x as 1, right? So we have x is equal to 1. So we have y is equal to x and x is equal to 1. So therefore y is also equal to 1, right? So the first set of values for x and y is 1 comma 1, right? So this is x and this is y. Now let us consider the second one. So here we have y is equal to 3x, which corresponds to m is equal to 3. So when we take y is equal to 3x in the first equation, we'll get 4x cube plus 3x square times y. So for y, we can now write here 3x plus 3x cube, that is equal to 8, right? So now we have 4x cube plus this is 9x cube, and here we have 27x cube is equal to 8. So this is 9 plus 4, 13 plus 27, that is 40x cube is equal to 8, right? So x cube is 8 over 40, that is 1 over 5. So x is the cube root of 1 over 5, right? So x is equal to cube root of 1 over 5, and the corresponding value of y can be obtained by taking x over here, right? So we have 3 times the cube root of 1 over 5, right? So the second pair of values of x and y is given by cube root of 1 over 5, and 3 times the cube root of 1 over 5, right? Now let us take this relation. right? So here we have y is equal to 4x corresponding to m is equal to 4. So now taking y is equal to 4x in this equation, we'll get 4x cube. Then we have 3x square times 4x plus y cube. Y cube can be written as 4x cube is equal to 8, right? So now we have 4x cube, then we have 12x cube, and here we have 64 x cube is equal to 8, right? So now here we have 12 plus 4 16, 16 plus 64 is 80, so we have 80 x cube is equal to 8, right? So x cube is 8 divided by 80, that is equal to 1 over 10. So x is, or x cube is 1 over 10. So from here we can write x is equal to the cube root of 1 over 10, right? So when x is cube root of 1 over 10, the corresponding value of y can be obtained by taking x is equal to cube root of 1 over 10 over here, right? So now y is equal to 4 times the cube root of 1 over 10, right? So the third pair of values of x and y is the cube root of 1 over 10, and here we have 4 times the cube root of 1 over 10, right? So viewers, this is how we can obtain or we can solve these two equations. So the solution of, or the simultaneous solution of these two equations can also be written as x is equal to 1 when y is 1, and here this pair can be written as x is equal to 1 over cube root of 5, and y is 3 times, or 3 over cube root of 5, and here we have x is equal to 1 over cube root of 10, and here y is equal to 4 divided by cube root of 10, right? So viewers, this is the required solution of these two simultaneous equations, right? And here in this lecture we have seen how beautifully and how elegantly we can solve these type of equations by substituting y is equal to mx.